Jai Ram Ji ki. The topic is sampling. The objective of this topic is importance of sampling in analysis of food. We will describe different sampling techniques and find ways to draw a representative sample from the lots, prepare sampling plans, and we'll talk about standards and guides on sampling. So what is a sample? Sample is nothing but a portion of a product, a small piece from the bulk, which we call also as lot, a fraction of the bulk, which we call as population. So basically sample is a namuna, in Hindi we say. Why do we need a sample? Because we want to get an idea about features of a product or lot or population. From the sample, once we draw and check that sample, if it is representative, we can know details about the whole lot. For example, अगर हम चावल बन रहा है और एक पीस चावल का निकाल के चेक करते हैं तो हमें पता चल जाता है कि पूरा चावल पक गया या गल गया, पक गया या नहीं पका. So this is the importance of a just small piece of sample. Sample or specimen, it must be representative of the lot, then only we can draw the conclusion which is right. अगर हमने एक चावल चेक किया और उस चावल से पूरे चावल के लॉट का पता चल गया, so that means it is the representative of the lot. Now what is the purpose of a sample? कई कारणों से हम सैंपल ड्रॉ करते हैं. सबसे बड़ा कारण जिसके लिए हम सैंपल ड्रॉ करते हैं वो है पर्पस ऑफ एक्सेप्टिंग और रिजेक्टिंग द लॉट बेस्ड ऑन क्वालिटी, whether the food meets quality criteria including its fitness for human consumption. Human consumption fitness is the most important criteria जिसके लिए हम सैंपल कलेक्ट करते हैं. Also we collect the sample for grading of foods based on constituents, safety of the food and shelf life of the food. So we can say that sampling is for checking quality. Sampling is done for checking the grade of the product, like for example different grade के जो product होते हैं, compliance with standards, verification of what is written on the label and its microbiological parameters and shelf life. So basically sample and sampling, they play a vital role in food trade in accepting or rejecting a lot of foods. So what is a lot or population we must understand. Population is nothing but a number of packages like containers जिसमें food products packed हैं, a batch which is there in the stockyard, or a large number of batches which are put, or large number of products which are put in warehouse. Size of the lot or of population is very important for preparing the sample plan. It may be of a batch, like a lot can be of a batch of a product manufactured. Remember, if we are taking a sample from a lot which is nothing but a batch manufactured in the plant, then we must remember that the batch is generally prepared under the same conditions at the same time, and the lot is basically a finite lot. We can also have samples from number of batches. So a lot can also be a consignment, a product batch, or lot of materials packed in the warehouse. So based on the lot side, we decide about the sampling plan कि sampling कैसे करना है. But why sampling? Why should we have a sampling plan? We know sampling is for to evaluating the lots. एक सैंपल हम लॉट का कलेक्ट करते हैं, तो लॉट के बारे में जानने के लिए हमने सैंपल किया है. सो इट इज़ नेसेसरी टू ड्रॉ अ प्रॉपर सैंपल फ्रॉम द लॉट. अगर सैंपल ही प्रॉपर नहीं होगा तो लॉट के बारे में हम पता नहीं कर पाएंगे. नाउ नॉट पॉसिबल टू चेक लॉट एज सच. सो सैंपल इज़ ओनली एन एस्टिमेट ऑफ द वैल्यू ऑफ पॉपुलेशन, but by which sampling technique we use, we can make it an accurate estimate. So what should be the appropriate method of sampling? And method of sampling is very, very important to get the accurate results about the lot. So accuracy of extrapolation of information from a sample of a production lot is very high. We know very well that a production lot is nothing but a batch, because lot is finite. जब sample lot finite है तो उसकी यूनिफॉर्मिटी हाई है. बट इफ़ इट इज़ इनफाइनाइट, लाइक नंबर ऑफ बैचेस पैक्ड इन अ वेयर हाउस, or number of products, number of containers which is very large kept in the warehouse, then it is infinite lot. So finite lot and infinite lot, sampling will give different information. For finite population, sampling will provide estimate of quality of the lot. But sampling from infinite population, we will get an idea about the process involved. So data obtained from sampling provides information about compliance of sample lot with acceptable values as per specifications. So once we have a sample from the lot, and if it is representative, we will be able to know the essential quality parameters of the product, which has to be very accurate. And for accuracy, the sample has to be homogeneous. But we all know very well that in food products, especially the processed food, they contain of lot of materials. They contain hydrophobic material, hydrophilic material at the same time. They contain solids, liquids together. Ideally, a lot should be uniform throughout and identical at all locations. But that is not possible. It is possible only when the lot is liquid. For example, in a reactor, for example, in a vessel, we have liquid which is transparent like sugar syrup, like honey, which does not have any particles in it. So this kind of homogeneous lots, when we draw sample, the results obtained from such samples will be accurate and will talk about the lot very, very correctly, accurately. So we know very well that in practical terms, the food products are heterogeneous. They are never homogeneous. The polarity difference, the particles are of different sizes, shapes. So processed food contain various kinds of heterogeneity involved in it. The sampling plan should be as per the homogeneity and as per the heterogeneity, and taking care of the heterogeneity, we have to have a sample plan and adopt a sampling method. Generally, we follow the random sampling. Why random sampling? Because in random sampling, there is no human error involved. It is independent of human error. So chances of error because of judgment, because of the person's mistakes is ruled out. We draw the sample from several locations within a lot so that the sample is representative of the lot. For liquids, as I just said, if it is in small containers, we just shake the container, and if it is in large container, we may just aerate the container to bring homogeneity. But sampling from the solids like grains from a wagon, grains from a truck, or grains in the warehouse, mixing is impossible. So what do? We do sample drawing from different places, from various points in the lot, but again in the random manner. Now there are sampling errors involved in it in the case of solids. For example, आटे की बोरी में आप सैंपल ड्रॉ करेंगे तो उसको डिफरेंट कॉर्नर्स से आप उसमें से पियर्स करके लॉट सैंपल निकालेंगे, छोटे छोटे सैंपल डिफरेंट लोकेशन से निकालेंगे. लेकिन अगर आप ग्रेन्स में से सैंपल कर रहे हैं, चावल का सैंपल कर रहे हैं, गेहूं का सैंपल कर रहे हैं, दाल का सैंपल कर रहे हैं, तो पार्टिकल साइज एंड शेप के अनुसार सैंपल डिफरेंट हो जाएगा. अगर राउंडेड पार्टिकल्स हैं और अगर राउंडेड पार्टिकल्स हैं इजीली आ जाएंगे, लेकिन अगर डिफरेंट शेप्स में पार्टिकल्स हैं तो उसमें ट्रायर में आएंगे नहीं. इसी प्रकार से यदि मान लीजिए सॉलिड आपका हाइग्रोस्कोपिक है तो वो स्टिक भी कर सकता है सैम्पलिंग डिवाइस से. सो वी हैव टू बी वेरी वेरी केयरफुल अबाउट एट द टाइम ऑफ ड्रॉइंग दी सैम्पल. अगर सैम्पल हम हॉरिजॉन्टली ड्रॉ कर रहे हैं या वर्टिकली ड्रॉ कर रहे हैं उससे भी अंतर पड़ेगा. सो इन हॉरिजॉन्टली ड्रॉइंग सैम्पल्स लार्जर अमाउंट ऑफ स्मॉलर साइज पार्टिकल्स विल कम. In vertically drawn samples, it will be much less. So method of sampling will play a vital role in this case. After we have collected the sample, we must remember that collection of sample has to be done in a manner that the reliability of analytical data are absolutely perfect. The collection of the sample, representative sample, has to be sent to the lab. The lab should prepare the sample, and the preparation of the sample is done as per the analytical method involved. So basically 3 steps are there. We collect the sample, we prepare the sample for analysis, and then we analyze the sample. Now remember, these 3 steps are independent of each other, but each one of them have a decisive influence on each other. So we have to be very, very careful in not committing any error at any stage in these 3 steps. So we should have a plan for each activity with quality standards and standard operating procedures. Proper sample size, suitable containers for sampling, these are all, and how to preserve the sample so that it doesn't get spoiled. How do we transport the sample before the analysis? All that is to be very carefully done so that there is no error at collection stage. So for accurate result, care of sampling and sample preparation, starting from collection of the sample at the sampling site and then preparation of the sample at the lab site. Now let us take an example. Suppose as per standards we are given the sample of grapes. We pick up 3 kg of grapes from a lot of about 10,000 kgs. Now if the sample is improper, the results will be different. The same sample given to different labs will give different results, and lab to lab variation, sample to sample variation. So what we say, we will say that the labs are not up to date. We question the capability of the labs, but we do not question the lapses while drawing the sample and collecting and preparation of the sample. So these aspects also have to be very clearly understood. Now let us take an example of a study carried out for analysis of aflatoxin in groundnuts, peanuts. Now the level at which the analysis was done was 20 nanograms per gram, and it was found out that 60% of the error was due to the total variance error was due to sampling, and due to the analysis and due to the person doing the analysis, only 20% and 13% error. Similarly, a pesticide residues analyzed in grape samples during the residue monitoring of grapes, and 15 individual grape bunches were analyzed from 1 acre area. It showed that 50% of the sample induced variation was there. So that means sampling caused 50% was responsible for 50% of the error in the results. So residues, and the reason for that is deposited on all the grapes uniformly. They are there in certain grapes. Similarly, the aflatoxin may not be there in all the peanuts and groundnuts. Maybe only some groundnuts are affected by aflatoxin. So when we draw the sample, all these aspects we have to be very, very carefully doing it. Improper sampling will lead to improper results, inaccurate result. Now let us talk about risk associated with sampling. There are 2 kinds of risk. One is risk called consumer risk, and the other one is called vendor risk. Now what is a consumer risk? The actual acceptable probability of a consumer risk depends on the consequences. Now what are the consequences? Suppose if we have accepted an unacceptable lot. So from the point of view of consumer, if the consumer is getting a product which is actually unacceptable but has been accepted, so these may vary from major health hazards. I mean, it can cause food poisoning, it can cause fatalities. It's very, very serious. Whereas the demand for low or no probability is there for such cases. But in cases where the health hazards are not that much severe, then it will be allowed to occur more frequently. ऐसा होता भी है. जैसे मान लीजिए आप मार्केट में जाते हैं, आप फल सब्जी परचेज करने जाते हैं. जब आप देखते हैं तो सपोज टमाटर हैं. अब अच्छे टमाटर हैं जिनमें कोई फॉल्ट्स नहीं है, कोई डिफेक्ट नहीं है, उसका एक रेट है. उससे कुछ इन्फीरियर क्वालिटी के टमाटर हैं, वो वहीं रखे रहते हैं सब्जी वाले के यहाँ. आप स्वयं उसमें से पिकअप करते हैं कि कौन से आपको कोई हानि नहीं होगी, तो आप चीपर टोमेटो उसमें से स्क्रीन आउट कर लेते हैं, सेलेक्ट कर लेते हैं. इसी प्रकार से आप जब केला खरीदते हैं, सेब खरीदते हैं, तो किसी पे छोटा छोटा स्पॉट होता है, बिकॉज वो हेल्थ में इतना हैजर्डस नहीं होता, तो यू आर अलाउइंग इट. कस्टमर रिस्क इज़ नॉट दैट मच. बट यदि मान लीजिए आपका कोई प्रोडक्ट बहुत स्पॉइल्ड है और जिससे आपको हानि हो सकती है, विच कैन बी फैटल, तो आप बिल्कुल एक्सेप्ट नहीं करेंगे. In the case of vendor risk, it is the probability of rejecting an acceptable product. An acceptable probability of vendor risk is generally 5 to 10%. So it is not that high, and the care is taken to ensure that the consumer risk is minimized. What are the sampling errors? Let us talk about it. So there are three terms. One is variance, the other one is precision, and third one is accuracy. Remember, we have talked about three aspects: number, sample collection, sample preparation, and analysis. Variance would be there at each level, and variance is the estimate of uncertainty. So total variance in analysis and producing a report will be addition of variance at each stage. What is precision? When we analyze a sample and reproducible results are obtained, that means repeatability is very high. Each time a laboratory analyzes a sample, prepares a report, if the result is same, then it is precise results. But whether the result is accurate or not, that is very important. Important is of course precision, but we have to have precise results with accuracy. And what is accuracy? Accuracy is the results are true to the value. What is the actual value of the product? If same value the analysis is giving, then it is accurate results. So accurate result all the time reproducible is the desired, that is the goal for doing the sampling. So variance has to be minimum, precision has to be high, but the focus has to be on accuracy. Now let us take an example of flour. Flour sampling as per AOAC method 92508. Okay, so the number of sacks which are to be sampled in the flour, we generally follow a principle as per this method, square root of number of sacks in it. Now frequency of sampling, like the lot is available, how frequently you will sample, it will depend on how much is the exposure. यदि मान लीजिए वो sack is exposed to degrade to environmental conditions which can affect its shelf life, then we will sample it more frequently. For sampling this, we use the trier, cylindrical trier, which is made up of course metal, 13 mm dia, and it will have a sharp slit, okay, which is of the 1/3 of the circumference. So at one end we will pierce it and take out the sample. The next sample when we draw, it has to be exactly from the opposite side of the sack. So like this, from different points, different locations, we will draw the sample, and from different sacks we will draw the sample and use separate container to stock to each of from the samples drawn from each of the sack. We will use different containers to store the sample. Now factors responsible for a sampling plan. While devising a sampling plan, what are the factors we should keep it in mind? First, we should keep it in mind for what purpose we are doing the sampling, the inspection. Suppose we are doing it for accepting or rejecting a lot, then the planning has to be different. To measure the average quality of the lot or to determine variability of the product. For these purposes, as per the purpose, the sampling plan would be devised. Then we should also keep it in mind the biggest factor, that is the nature of the product. If the lot is heterogeneous or homogeneous, we have to take care of our sampling plan in a manner that all aspects of heterogeneity are removed or taken care of. Unit size, how big the size of the lot is, how frequently earlier lots passed. We must also see there are two kinds of lots, continuous and non-continuous isolated one. In the case of, for example, a product which has been tested earlier, which is known, about which we know, which is known for its quality, then how frequently earlier lots had passed and how frequently they were rejected, that also will play a role in sampling. What is the cost of the product? Of course, it is important, but it is not important when we are talking about health and hazards involved in the sample, the lot that is to be accepted or rejected. Now, the next one is nature of the test method. What are the kind of test method we are going to adopt to analyze the sample, whether it is critical or minor, passing or failing, vital for health, whether it is hazardous if the sample is passed or it is non-hazardous, the test method is destructive, and what is the testing cost. Accordingly, we will draw the sample, we will carry out the sampling. Nature of population and lot. How big the lot is, how large the lot is, how uniform the lot is. Lot consisting of smaller, easily identifiable sublots, that also we have to keep it in mind. And distribution within the population. How a lot is proper, different kinds of For example, containers like 100 ml packing, 250 ml packing, half liter packing, 5 kg packing, 10 kg packing. So distribution within the population, and maybe from one source, maybe from different sources. So these are the factors we have to keep in mind while drawing the sampling plan. The sampling is generally done by statistical sampling, or we also call it probability sampling. It is also called simple random sampling. We must know the number of units in the population, as already said, assign each unit a number and select a quantity of random numbers from 1 to total number of lots units to be sampled. Determine the sample size and potential impact of a consumer or vendor error. We have already talked of consumer risk and vendor risk. That we should keep it in mind while taking into account the statistical sampling. Units corresponding to the random numbers are the estimate of the population, we must remember. Now, systematic sampling is used when a complete list of sample unit is not available. Like we are not checking a batch which is their production batch or something. When the complete list is not available, we do systematic sampling. But when samples are distributed evenly over a time or space, such as on a production line, first sample selected randomly and then every nth unit after that is done systematically. The next sampling way is stratified sampling. That means we divide the whole population, the lot, into strata and subgroups, so that each subgroup, and we divide it in such a manner and that each subgroup is as homogeneous as possible that we can select. Random samples are then drawn from each subgroup. Let us see how does it look like. This is stratified sampling. We have on the left side population. We divide that into strata, and from each strata we do the random sampling, and we have then samples for analysis. The next one is cluster sampling. There we divide the population into clusters or subgroup so that clusters characteristics are as identical as possible. This is based on the characteristic. First, clearly define the population and then divide it into clusters having diverse population. Every potential characteristic of entire population be presented in each cluster. We must make sure. Each cluster must have similar distribution of characteristics as the distribution of the population as a whole. This is very, very important. And taken together, the sample, the cluster should cover entire population. So basically what we are doing is we are taking a population, divided into clusters, but we should draw the sample in such a manner that from each clusters the sample drawn must represent the entire population which was divided into clusters. No any overlap between clusters. Clusters should be small and having similar number of units in each cluster because there must be homogeneity as much as possible. Clusters are sampled randomly and may be either totally inspected or subsampled for analysis. Then we do the composite sampling, that is more in the case of bulk sampling when we do used obtain samples from bagged products such as flour, seeds, larger items, grains. So two or more samples are combined together. So number of samples we collect. So we combine them together, make a composite sampling before analysis. Let us see cluster sampling. This is first we define the population, the complete population. We make clusters. As you see here, we try to do clusters in such a way that the samples from all the clusters, the whole population is represented there. With these words, I say thank you very much for the time that you have given for this part of sampling. Jai Ram Ji ki.